Hello, everyone. Today we'll be talking about functions and developing some intuition for one-to-one and onto proving and disproving. So a function, just to recap, is some mapping from a domain A to a codomain B. And we know that like the range is a subset of the codomain that F is actually mapping to. And for couple key things about functions are that every input has exactly one output. So you can't have something where maybe your function tries to map one value in the domain to two different things in the codomain. Will not be a function. Also consider the domain and codomain carefully. For example, if you have this like function f of x equals 1 over x, and you're trying to map from all real numbers, f of 0 doesn't map to anything because 1 over 0 is undefined, so this would not be a function, but if you excluded 0 from the domain, then it would be. So let's now talk about onto and one-to-one. So onto, in this case, the range is equal to the codomain. In other words, for everything that we have in the codomain, we have something in the domain that maps to it. And so let's consider this function where, let's just say first, okay, we have g going from positive reals to the real numbers, and we say, okay, g of x equals 3x. You might think at first glance this would be onto, but if you thought about this, maybe you, to develop some intuition, just plugged into a few numbers and said, okay, let's take some number in the reals. Maybe I'll take 1 and say, okay, how do I get to 1? G of some a equals 1. Well, I could say here I'll take 1 over a, and I can say, okay, or 3a equals 1. So then a equals 1/3. So I can map to 1 here. But if but I can try something that's not in the positive reals and say, okay, let's try -1. G of what number? What input can I get to get -1? So I know that whatever we take g of b, this would be equal to 3b, and this is equal to -1. We're claiming here, and so then I get b equals -1/3. So in order to map to this number positive or -1, I have to get -1/3, but this is not an element of my domain. My domain is the positive reals, and this is the negative real. So I've just proven that, in fact, G is not onto because I found a counterexample essentially to prove something's not onto, you find a counterexample. To prove it is onto, you assume some arbitrary element in the codomain, and then prove it can be found in the domain. So if suppose we had RG went from R to R instead, then it actually would be an onto function. And then we could say, okay, we'll just choose some B in our codomain, and we're going to define some A such that we can map A to B. So I know that G of A is equal to 3A, and I'm wanting this to be equal to B. And so to do that, I'd say, okay, I'll let A be equal to B over 3. So then I'll plug in G of A over G of B over 3 is equal to 3 times B over 3 is equal to B. And so this would be an onto proof where I'm choosing some arbitrary element of the codomain, and then I'm finding a particular value. So here I found some value in terms of this B here, B over 3, such that G of this B over 3 maps to B. So it's important to plug it in and to find that like the arbitrary value here in order to show that it is in fact onto. One-to-one, the idea is that we have no two inputs mapping to the same output. It's very important here to not confuse this with the definition of a function. So the function is saying that no two outputs are mapped from by like the same input, and so that's the idea of a function. So oftentimes it's very easy to fall into the trap of, oh well, no two outputs are mapped to from the same input, so it's one-to-one, but it actually means that it's a function. And so more formally, we're saying that if we have two things in the codomain that are the same, then the thing that they're mapping from the domain must have been the same. Or if we have two different things in the domain, we have two different things in the codomain. And so let's consider this potential function here, g of x. And so we're saying g of x equals mapping from the positive real numbers to real numbers, and we're saying g of x equals 3 over 4x plus 5. Is this a function? So you might notice here that it's kind of similar to this idea of 1 over x. There might be something I can find to get 3 over 0, which would not be valid elements or valid mapping here. I couldn't map this to anything. So let's try, I want to get 4x plus 5 equal to 0. So I'll say, okay, 4x equals negative 5, x equals negative 5/4, and then I could plug this in and I would get 3 over 0. So as is, this is not a function. So it definitely can't be one-to-one. Let's consider what if we modify our g to be this h1, where we do the same thing if we are not negative 4/5. If we are negative 4/5, or rather, this should be negative 5/4. So then, if it's not, we'll just map to 1. So with this, but now we do have a function for sure. But this, you might think, okay, this probably is not one-to-one because I'm having a 1 here, and I might be able to find a 1 somewhere else. Let's try to find two values. If you can find two values that both map to 1, or we have two inputs that both map to the same output, we can prove that it's not a one-to-one function. So let's try, okay, I'll find something that equals 1. So I'll say h of 1 of negative 5/4 is equal to 1 from this kind of piecewise definition we have here. And then I'll also try to find some h of x such that this is 3 over 4x plus 5 is equal to 1. So I'll say 3 is equal to 4x plus 5. And I'll subtract 5 from both sides to end up with x equals negative 1/2. And then I'll plug this in. Okay, I'll say h1 of negative 1/2. That's 3 over 4 times negative 1/2 is negative 2 plus 5 is 3 over 3, which is also equal to 1. So here I found two different inputs, 1/2, negative 1/2, and negative 5/4, and they're both elements of the domain. They're both elements of the real numbers, and they map into the same output. So we've shown that, okay, h of 1 is not one-to-one. Let's try to modify this function again and try with h2. And we're saying, okay, we'll take essentially the same function we had with our g, but we'll just take negative 5/4 out of the domain. Then would this become a one-to-one function? And here this would become one-to-one. And so to show this, what we'll do is we'll consider we have, let's say we have a1 and a2, and we know that h of a2, or h, I'm just going to call this h for simplicity. H of a1 is equal to h of a2. And what does this mean? This means that we have 3 over 4a1 plus 5 equals 3 over 4a2 plus 5. And then you can multiply both sides here to get 3 times 4a1 plus 5 is equal to 3 times 4a2 plus 5. And then I'll drop the 3 from both sides to get 4a1 plus 5 equals 4a2 plus 5. And then drop the 5, 4a1 equals 4a2, and getting a1 equal to a2. And so then we've shown that in any case, these are kind of arbitrary a1 and a2 in the domain. So if we have two elements in the codomain map to the same thing, that means they must have had the same input. So this is enough to show that h2 is indeed a one-to-one function. So as kind of a quick recap of how to go about this, first of all, recognize, be very careful about looking at the domain and codomain, and kind of convincing yourself before proving that is this actually a one-to-one function, is onto. To disprove, I often find it's helpful to try to disprove first, look for counterexamples. So to disprove an onto function, you have to find something that we can't map to, which we actually, yeah. And so here we found that, okay, we can't map to, oh, I erased it, but we couldn't map to -1. And so we found a counterexample, so then it's not an onto function. There was something we couldn't map to in the domain. For, to disprove a one-to-one function, we find two elements that are different in the domain after the same element of the codomain. And then to prove something is one-to-one, we consider two arbitrary elements that have the same output, and then we show that these must have been the same input. We also could do it by choosing two different inputs. So you could choose two different, like A1 and A2, where we know that A1 is not equal to A2, and show that we must have different outputs. Would also be a valid way of doing this. And then for an onto proof, we choose some arbitrary element of the codomain and show that it is mapped to by some element of the domain. That's kind of a quick overview of functions and kind of intuition behind proofs. Thanks for watching.